Welcome again to this lesson as we are going to go through this organic chemistry guide. This is the whole of organic chemistry guide, the content that a student needs or the key tested areas in organic chemistry, which includes organic chemistry 1 and organic chemistry 2. This is a guide of organic chemistry, which is a most critical part of the syllabus where most of the learners tend to confuse, and it gives them a bit challenge in handling questions. And remember that organic chemistry is tested in both paper 1, paper 2 and both paper 3, and this is where you can see this is the most important topic which covers both papers. It varies from paper 1, paper 2 and paper 3, and in paper 2 these questions are always tested as questions constituting 10 to 11 marks, and in paper 1 of course you are being tested 2 to 3 marks or even 1, and in paper 3 organic chemistry practical, which includes also includes alkanoic acids at some point. Now remember, this organic chemistry 1 and 2 both vary and are well distributed in form 3 and form 4 syllabus, such that organic chemistry 1 is in form 3 and organic chemistry 2, which includes alkanoic acid and alkanols, is in form 4. Now let's start from organic chemistry 1, and let's start directly into the objectives, specific objectives that a learner needs to achieve. By the end of the topic, the learner should be able to define a hydrocarbon. As you can see, define a hydrocarbon, which in most cases a hydrocarbon consists of it's a substance that consists of carbon and hydrogen, or a compound that is made of carbon and hydrogen, and that's a hydrocarbon. Name and draw the structure of simple hydrocarbons, which includes alkane, alkenes and alkynes. This varies from the number of carbon atoms from alkane, alkene and alkyne, and the number of double bonds linking the carbon atoms. For example, in alkenes we have only one bond, one single bond, and in alkenes we have a double bond, and alkynes we have a triple bond, which includes 3 lines. In alkane we just have 1 line. In alkenes we have 2 lines representing double bond, and alkynes we have 3 lines representing triple. In C, state the features of homologous series. Draw and name isomers of simple hydrocarbons containing not more than 5 carbons. This is where we talk about polymers. Describe general methods of preparing alkanes, alkenes and alkynes. Explain the physical and chemical properties of alkanes, alkenes and alkynes, and state the uses of alkanes and alkene and alkyne. And those are the specific objectives that a learner should be able to do or to state or to know by the end of the topic organic chemistry 1. Now into the content. The content is that we have alkanes. This one, you must know the definition of a hydrocarbon. As we say, the hydrocarbon is a compound made of hydrogen and carbon. The general formula of the hydrocarbon, the occurrence, the nomenclature, considering straight chains of up to 10 carbon atoms. Yes, as you can see, this situation of chains, you can see starting from alkanes, their nomenclature, and straight chains of up to 10, whereby we have methane. We have the methane starting from ethane, methane, going propane, butane, pentane, hexane, heptane, like that, going up to the 10th one. Now isomerism, butane and pentane, isomerism of butane and pentane. Now let's go to the next page. Let's go to the next page. What does the next page says? In the next page, we got to have the continuation. Also the continuation, whereby we said preparation of methane and ethene. Yes, this we have talked it. We have talked about it. Preparation of methane and ethene. Trends in physical properties: melting point, boiling point, density, and solubility. As you can see, the homologous series is one that I've named above. That homologous series starting from ethane, methane, propane, butane, pentane, hexane, heptane, going all the way to the 10th one. That is the homologous series. Now the boiling point, you should be able to identify whether it starts from whether ethane has the boiling point or the last one. Going down the series, you will see the variation. Trends in physical properties, we have talked about. Chemical properties: burning and substitution, or this one also you can say combustion or burning. Substitution reaction with chlorine, bromine. Details of the reaction, mechanism not required. As you can see, details of the reaction and mechanism is not required. And then finally, uses of alkanes. And finally, you talk about the uses of alkanes. Those are the most key details when handling this question. Now, on to alkenes. The general formula, you should be able to know the general formula of alkenes. The nomenclature: consider straight chains, alkenes of up to 6 carbon atoms. The isomerism, these are small chains, called isomers, small units, isomers. Preparation of ethene. Trends in physical properties, also melting point and boiling point, solubility in water and a non-polar solvent. Whether a non-polar solvent is a solvent that does not dissolve in water, while a polar solvent is a solvent that dissolves in water. Now, chemical properties, including combustion, addition of chlorine, bromine, hydrogen halides, and ethene. Details of mechanism not required. Again, the test for unsaturation. This is mostly in paper 3. Also, this test of unsaturation. The test of unsaturation, this means it has some several bonds, whereby the one that has a single bond is a saturated hydrocarbon. The one that has a single bond is a saturated hydrocarbon, whereby it has a more number of hydrogen atoms. As you can see, unsaturation, for example, if we say alkane is a saturated hydrocarbon. Alkane is a saturated hydrocarbon, while alkene is unsaturated hydrocarbon because of the double bond it has. And the test for it, it's tested using the acidified potassium manganate 7 or bromine water. Acidified potassium manganate 7 or bromine water. That's the test of unsaturation, and this is mostly tested in paper 3. Use of alkenes. Finally, that's the use of alkenes. Now into the third one, which is alkynes. Alkynes. What is tested in alkynes is the general formula and the nomenclature. Consider straight chains of alkynes is up to 6 carbon atoms. The isomerism as usual. The preparation of a thine, trends in physical properties and boiling points, considering the homologous series as we said, density, solubility in water and non-polar solvent as we've talked about. And also here we'll talk about chemical properties, combustion, addition, reaction with chlorine, hydrogen and bromine, and also hydrogen halides. Now finally the uses of alkynes. That's the most that's the end part of it, the uses of alkynes. On to organic chemistry 2. This is a topic in form for now. Organic chemistry 2. This is where we are going to talk about alkanals and alkanoic acids. Alkanals and alkanoic acids. Specific objectives. By the end of this topic, the learner should be able to name and draw the structure of simple alkanols and alkanoic acids, describe the preparation and explain the physical and chemical properties of alkanols and alkanoic acids, state the main features of homologous series, state and explain the uses of some alkanols and alkanoic acid, describe the preparation of properties and uses of detergents, explain the effects of hard water on detergents, list some natural synthetic polymers, fibers, and state their uses, describe the preparation, properties, and uses of some synthetic polymers, identify the structure of a polymer given the monomer, state the advantages of synthetic materials compared to those of natural origin in terms of both structure and properties. Now, on to the content. Let's start from alkanols, because here, as you can see, we are discussing about alkanols and alkanoic acids. Now start from alkanols. The general formula of alkanols is ROH, nomenclature or primary alcohols up to 10 carbon atoms. That's the general formula of alkanols, is the ROH. Now let's go into this section. That's the continuation, continuation of our discussion. Also here I will talk about them. Also here the preparation of alkanols from using two methods. That the preparation of alkanols from two methods, which includes the hydrolysis of alkenes and fermentation of carbohydrates. Those are the two methods of preparation of alkanols. That's from the lab. That's hydrolysis and hydrolysis of alkenes and fermentation of carbohydrates. Now the physical, you should be able to know the physical properties of alkanols also. The gradual change in physical properties, of primary alkanols. Mention hydrogen bonding also. Another one is chemical properties, reaction with oxygen, burning sodium, concentrated sulfuric acid, and also ester formation and the oxidation to give alkanoic acid. Also uses of the alkanols. This is the final details, the uses of alkanols, which includes used as solvents, fuels, and pharmaceuticals. Now onto the alkanoic acid. Alkanoic acids, as you can see, the general formula of alkanoic acids is RCOOH. But here there is supposed to be a small hyphen between R and C, and RCOOH, that's a primary alkanoic acids up to 10 carbon atoms. That's the nomenclature in other terms. Now preparation by oxidation. Preparation is by oxidation of primary alkanols. Alkanoic acids. To prepare an alkanoic acid, we are going to oxidize the primary alkanol, which is, let's say we want to prepare an ethanoic acid. We are going to prepare it from methanol, which is a primary alkanol. Or we want to prepare methanoic acid or ethanoic acid, or let's say we want to prepare butanoic acid. We are going to prepare it from butanol, which is a primary alkanol. Now you talk about again physical properties, gradual change in physical properties. Alkanoic acids mention hydrogen bonding also. Now in chemical properties, reaction with acids, salts and esters, alkaloids, formation of two carbon atoms only. Note that equations involving these reactions are required. Note that equations involving these reactions are required. State symbols are not required. Here in this section, in the section of organic chemistry, state symbols are not required, but the equations are more important. Now into soap and detergents. We'll be able to look about the soapy detergents or soaps. Laboratory preparation by hydrolysis of fats and oils with alkalis. Hydrolysis, the preparation of soaps using this method of hydrolysis of fats and oils with alkalis such as sodium hydroxide in the lab. Or mode of action. Yes, we should also look at mode of action of soaps, and we'll also look about water hardiness and pollution effects. Those are the key areas required. Then soapless. Now into soapless detergents. Now in these soapless detergents we will see about their manufacturing, also their mode of action, and also their pollution effects. Now on to polymers. In this section of polymers, the students is expected to name some natural polymers and fibers, which include cellulose materials, which includes cotton, wood, paper, and silk, and also hydrocarbons, which includes rubber and its vulcanization. By the vulcanization, this is the process of hardening of rubber. Vulcanization is the hardening of rubber, and this process mainly involves when making tires. Vulcanization, the hardening of rubber. In this section of polymers, the student will be also expected to be able to name the names of synthetic polymers and fibers, as we have already discussed about these natural polymers, and we said cellulose materials such as cotton, wood, paper, silk. These are natural, and also hydrocarbons, rubber, and its vulcanization. Now into synthetic or artificial. This includes polythene, polychloroethene or PVC, polyphenyl ethene or polystyrene. We also have terylene, nylon, and perspex. And remember, in this section, their equations are most important also. Now, synthetic rubber. This is the final one, synthetic rubber. And in this synthetic rubber, we got have preparation and uses of synthetic polymers. This is also the last topic, the last part of it, preparation and uses of that synthetic polymer. Preparation and uses of that synthetic polymer. Now let's finish the very last part of it. Which includes this is the very last part. Which includes equations to show addition polymerization. For example, formation of polythene, polychloroethene, polyphenyl ethene, and their advantages and disadvantages of synthetic polymers and fibers over those natural origins should be mentioned, including biological degradability of materials. Uses of polymers should also be expected for a student to know, and fibers. Manufacture of beer, spirits, soaps, and detergents. Those are some uses of polymers and fibers. Also manufacture of drugs in textile industry, packaging materials, pipes, and tires. Those are some uses of these polymers. And the final part is the project one, whereby you should be able to carry out some of these projects or tests in your lab with your teacher. Fermentation of various carbohydrates to produce ethanol, soap preparation, investigation of effects of soaps on detergent on aquatic life, investigate methods of recycling and disposal of plastic, and also investigate the strength of polymers. And that marks the end of our presentation today, of our lesson today about this organic chemistry guide, which is a most critical part for student, where the student mostly needs in order to answer questions in paper 1, paper 2, and paper 3, and mostly tested in every section and in every paper. And this is the guide I already given to you, and there is no excuse for a student to fail having tackled the most key parts tested, to avoid reading a bulk of things that may end up not be tested. These are the only key and important parts that organic chemistry will test. Finally, this is our conclusion, and I want to thank you again, and follow my channel, subscribe for more content, including chemistry revision papers KCSE 2026, and also some teaching learning lessons, and also for more papers for revision. Thank you.